Now we're going to put these gas laws into problem solving. And so we look at this and we have, remember, STP is standard temperature and pressure. First of all, understand that. Also remember, temperature always has to be in units of Kelvin. And just for pressure and volume, at this point in time, just remain consistent. That's the key. So as we go on to our first problem, it says calculate the volume of 100 milliliters of gas at 10 degrees Celsius when it is heated to 112 degrees Celsius. So what I like to do first of all is I like to identify what I know. And this is key because this is what we call the Google Map technique. Identify what I know. With all these variables, I then realize, oh, I have V1 over T1 equals V2 over T2. I have Charles' law. I give you these equations just by this alone. Instead of reading the problem over multiple times, take the time to get the information down. So looking at this, I then realize, well, my volume's in milliliters, my temperature has to be in Kelvin, so I have 10.0, one digit to the right of a decimal, so I have to keep one digit to the right of a decimal, 273.15, the 5 rounds of 1 up to a 2, so 283.2, and then my 112 is the even number, so I just straight up add 273, and now I've realized my equation. Now what I like to do with my equation, and some of you again to help you out in this process, what we'll do, I brought up the suggestion for some of you is that some of you need to actually want to cross multiply. As you cross multiply, then what you'll do is you'll make it into a linear equation. So now your equation looks like V1 times T2 equals V2 times T1. Now you're in a situation where you realize, okay, I want to isolate, in this situation I want to isolate my V2, so I'm just going to divide both sides by T1, and that can help you out in the process of giving yourself a working equation. Those cancel out, there's your working equation. That can be very helpful in that process of doing that, and so that's what I do strongly suggest you do. It's a technique that's going to save you time, especially later on. So now I realize all I'll do is multiply V1 times T2 divided by T1, and I get my answer. My Kelvin cancel out right here, and I end up with 204 milliliters. I would accept 3 sig figs, or if you want to put it in 2 sig figs, you would, 204 falls back to 200. You would have to put it in scientific notation if you did that. Remember, scientific notation requires one digit to the left of the decimal. So you move it over 1, 2, that's why it's 10 to the second. Remember that if you put a number in scientific notation. The next problem says what pressure of the gas in a 5-liter tank exert if it is heated to 150 degrees Celsius. It was originally at STP. So again, I know my original volume. I know my temperature at STP, and I know my pressure was originally at STP. I just put 1 atm right away. So I have no unit for pressure right now, and 1's the easy number to work with. I do know that my final temperature was 150 degrees Celsius, and I'm asking you what would the pressure be, so I know my P2. What I realized right away is one is not changing my volume. I don't even need my volume. So then I realized, oh, I'm dealing with Gay-Lussac's law. It's P1 over T1 equals P2 over T2. And that's going to be very, very helpful. Like I said, you identify this information and you walk through it really quick. So you realize, first of all, again, STP, there's my Kelvin. I add 273, it's a whole number. I get 423 Kelvin. Make sure your temperature is in Kelvin. As for sig figs, I look only at my measurements. Do not look at STP for sig figs. So I look at my only measurement I have has 3 sig figs. So my answer I know is going to have 3 sig figs. So all that's kind of going on in your mind as you're going through this problem. I give myself this equation. Again, I like to cross multiply. In the situation, as we cross multiply here, we then get a working equation of P1 times T2 equals P2 times T1. You're going to isolate P2, so you're going to divide both sides by T1 again in this situation, and you're going to end up solving for P2. So it gives us a working equation. I strongly suggest, however you get to this working equation, whatever works out for you, get there. Because now you're going to realize all you have to do is multiply P1 times T2, divide by T1, and you're done. And like I said over and over, it's just simply data entry. So my answer ends up being 1.55 atm. The next problem is what volume of 5 liters of gas at STP occupy at 50 psi. In this situation, I again document everything I know. I was originally at STP. In this situation, I realize my volume's in 5 liters. I have a final pressure, but I realize in this situation, my original temperature never changed, so I don't need it. Even though I know it's at SCP, I don't need it because it never changed. What I did do is this: because my PSI, my pressure ends in PSI, I use the equivalent to 1 ATM, which is standard STP. So it's equivalent in terms of PSI as 14.7 PSI. It's the same as 1 ATM. So I substituted that in just so I wouldn't have to change my units around for my pressure. And then I realized, okay, I'm dealing with V1, P1 times V1 equals P2 times V2. To isolate V2, simply divide both sides by P2. Then mathematically, I'm just P1 times V1 divided by P2. PSIs cancel out and end up in liters. 1.47 liters. As for sig figs, this has 3 sig figs, that has 3 sig figs. Never look at SCP. So both those measurements I had at 3 sig figs. Therefore, my answer at 3 sig figs. Number 4, it was a volume of 500 milliliters of gas at SCP when the temperature is raised to 50 degrees Celsius and the pressure is reduced to 50 kilopascals. So I realized I'm originally at SCP, so everything, this is what I originally have. I know that my temperature was changed to 50 and my pressure was changed to 50 kilopascals. So in this situation, I realized everyone is actually active. So my volume's already in milliliters. I'm solving for volume. My answer will be in milliliters. SCP for temperature is 273.15 Kelvin. My SCP for my pressure, well, I'm in kilopascals, and I know that 1 ATM equals 101.3 kilopascals. So I'm going to use 101 in this area right there. So with that, plug that in my 101.3 kilopascals. What temperature in Celsius I'll change is 50.0, 1 digit to arrive at decimal. So my answer out of 1 digit to arrive at decimal, the 0.15 rounds up to 0.2. And I'm ready to go. And so I have my working equation. And now this one really gets a little more involved with it. There's 6 variables here. So this one I really do suggest. Cross multiplying does make it helpful. Where you end up having P1 times V1 times T2 equals P2 times V2 times T1. And then the situation, realizing I'm going after V2. So I want to divide both sides by P2 and T1. A little bit of pre-algebra there. These guys cancel out. And there you go. You give yourself a working equation. But again, it's very valuable. However, like I said, however get there, give yourself a working equation. Now you realize it's just P1 times V1 times T2 divided by T1 divided by P2. Remember, divide each number in the denominator as if it were its own division problem. That's how your calculator thinks in this process. So you realize this, your kilopascals cancel out, your Kelvin cancels out, and you end up in a volume of 1,258 milliliters. As for sig figs, do not look at that. My original volume of sig figs, original temperature, my temperature right here is 4 sig figs, and 50.0 is 3 sig figs. My answer is only 3 sig figs, so 1,258. So my original answer, 1,258, has to bump up to 1,260. I would accept either one, in this or in scientific notation. Either one works out for me. The last one, we have 1,550 milliliters of gas is at a pressure of 955 torr is 0 degrees Celsius. So this is what we realized initially. If all the gases is transferred to a 5-liter container, that's my V2, and the temperature is Celsius, to what temperature Celsius must be heated to exert a pressure to equal STP, standard atmospheric pressure. So I'm going after T2. Everyone's changing. So first of all, I have an issue with my volume. I can either go to liters or I could change in both the milliliters. So I changed them to liters to show this. My original pressure is in torr. My second pressure, my P2, is at SCP, and I know that at SCP it's 760 torr. My temperature also, original temperature is 0 degrees Celsius, so I'll just add 273. It's a whole number, no digits to arrive at decimal, and I'm going to use 760 torr. So now all my busy work is done. It's a combined gas law. I always solve my unknown variable T2, again cross multiplying, making it linear, isolate the unknown variable, however you get there, get there. And so in this situation, then I'm going to solve there. So it's P2 times V2 equals, P2 times V2 times T1 divided by P1 divided by V1 equals. So we plug that in the calculator. Again, torr cancel out, milliliters cancel out. Actually, it's just what I did here. If you see here, I actually changed it back to milliliters. So this is an example of 5,000 milliliters. And I just did that so you can see that it doesn't matter what unit of volume you use, just be consistent. You're going to get up the same answer either way. So my final temperature there is in Kelvin. I want it in Celsius. So just like we add 273 to get from Celsius to Kelvin, we subtract 273 to get from Kelvin back to Celsius. Final answer, 428.